Oh, what was that? Oh, look at that. That's a gecko. Oh, look at that. That is bad.
Hey guys, we're on the west side. We got a trouble call for a sewage sump. Operators saying the pumps are switching back and forth rapidly and starting and stopping rapidly every now and then, not all the time. Operator said they cleaned the level transducer and looked at a few other things but couldn't figure out why. Probably gonna need to just connect my laptop to the PLC right away. There's no HMI here, so there's no interface to see what the computer is seeing relative to what's in the sump. So that'll probably be one of the first things I check is, connect to the PLC, the computer, with my laptop and see what it sees and what it's trying to do, and figure out basically what it thinks is going on, and compare that with the real world and see if it's any different from what the PLC is seeing. All right, I'll see you there.
Okay, so getting here. Upon arrival, pump selector switches are on off. Breakers for the soft starters are off. We've got two Automation Direct Stellar stop starters here. Everything's shut down. Did basic voltage checks just to make sure our supply voltage is good before we turn that on. Rule out any obvious major issues. Then the other thing I noticed before I powered anything up is on our BRX PLC, it is currently in stop mode, which I don't know why anyone would change that. Maybe the operators thought put that down. So yeah, we'll go ahead and power it up and see if we can get the same fault behavior to occur, and then start running through our checks, see what's going on. Okay, so for starters, when we turn this breaker on, we're taking 208 and making 120 out here. That 120 comes down and goes into this Eaton power supply, 24 volt DC power supply. The secondary of that power supply comes to these two fuses, DC1 and DC2. Those power supplies, one is running the PLC, DC1. What is DC2 running? DC2 may be running the soft starters. I don't have a wiring diagram, that's just panel specifications. Let's see. DC1. So DC1 right here runs the PLC and the soft starters. I checked those fuses for continuity. We don't have any blown fuses or anything. I think we're safe to power up. Let's go ahead and give it a shot. And then this should wake up the PLC. There's the blinking lights. That's good. Okay, so see how the run light is not lit? That means the PLC is not going to do anything. It's not going to call for anything. If we put these in auto, nothing should happen. I wonder if they'll even run in hand. They will run in hand. There goes 33 amps, 36. Yep, it's running. Good. Turn that off. There, it's ramping down. So hand works. That's a start. Let's put them in automatic. And to get this back into run mode, we have to go all the way up to run and then down to term. And then so far so good. Nothing is running. And then how about our inputs? We have X4 and X5 is true, but none of these relay outputs are firing. X0 and X1 are true. That's good to know. I think we can get a hose running in here and connect the PLC. So I wrote it over here on the door. When Y3 is true... Oh! Something just clicked. What was that? Why was that clicking? Okay, so when Y3 is lit up, see I don't have anything landed there, but I just made it an indicator for float mode. Y2 goes to the strobe, that's him, and Y1 is pump 2 and Y0 is pump 1. So here's our relay outputs from our PLC. They fire these relays, which tell them to start. I did just hear something click. That was odd. Yeah, I want to connect my laptop and see what the PLC is seeing as far as what the transducer level is. I want to see that live. I could connect my transducer level or my transducer troubleshooter to it. Oh yeah, look at that. Oh, look at that. It's definitely jittering. That's a gecko. Oh, look at that. Look at these outputs faltering, faults coming true. Ooh. That is bad. That is not good. Let's try removing the transducer. See if the problem goes away. So now we're in a transducer fault. Y2 is the strobe. So the fault we're in now is a transducer failure. I wonder if the transducer level is fluctuating so much. If the transducer level is fluctuating so much that it's calling for 1, it's calling for 2. That could be it. I think it'd be worth it to actually get my milliamp tester out and just see this analog signal raw with my tester. I think it'd be worth it. Let's put these guys off. Well, no, let's leave them in auto and see if it keeps flickering. I bet that's what it is. Or the transducer is healthy and the PLC's either analog input is starting to fail or there's something inside of him that's starting to fail. So let's get our analog transducer tester. Alright, so we got our Fluke 789. We're in source mode. We're going to go loop power. Put our red on our positive, our brown on our signal. And it's bouncing, not much. Oop. %, 5. So this is a percentage down here. This is the raw value in milliamps. As the liquid level rises, this percent should go up slowly. The fact that it's bouncing doesn't give me much confidence. Okay. Well, the next step I'd say we'll put this into the PLC, and then we'll look at the raw value on the PLC, and then what I can do is I can use this guy and have him pretend to be a transducer and generate a 4 to 20 milliamp signal. And if I put a clean, solid signal into my PLC and the signal stays clean and solid, then I'm happy with the input, and I'll probably recommend they get the transducer replaced. But what I want to do is verify that the computer and the input to the computer, to the PLC, is good before I just say change the transducer and get the hell out of here, because it could be more than one problem at once. It's usually how it goes. It isn't flickering anymore, though. I will say that. That's a good sign. And I'm not seeing too much of a jump. It really usually doesn't move at all. but it's only jumping 1 or 2%. I know we have a really tight bandwidth here though, between start and stop. So, okay, let's connect to the PLC with the transducer connected and see what kind of signal we're getting. Turn this off. There's our PLC address, because this panel was made by gentlemen who tell you how to get to things, leave you breadcrumbs. This is 192.168.1.2. Not seeing it. So let's see what our network settings are to make sure we're on the same. Network. We are 192.168.144, so that's why we're not seeing it. We need to change that to 1. About 50 will work, and we got to change the gateway to 1 as well. Okay, let's try that. Rescan. Let's try it. Sometimes I have better luck restarting the app. There it is. 192.168.1.2. There he is, 1.2. Give him a name. There we go. Okay, so I want to see data. I want to see the analog input is coming into WX0. WX0. So down here in data. And right now it's that 6,553 up to, God, I always forget that number, 3,000 something something something. So anyway, let's put our transducer back on. We'll put our pumps in off. Get a little tweaker screwdriver. Positive. There's our signal. And there it is. So there's our raw value. Oops. Man, that does not want to go in that terminal. Boy, what a poor connection. Get it in there. Let's try that again. There we go, there we go. Okay, that passes the tug test. And so yeah, here's our raw value. And it's bouncing. 7,008. Let's put them in auto. And there it goes. Yep, there it goes, doing it. Doing it, bouncing like crazy. That is not good. So now we need to verify if this bounciness is strictly because of the field device, or is it because of the actual analog input here in the computer that's receiving the signal? So what I'll do is get a little jumper wire and generate a signal with this guy. We'll look at it here, and if it doesn't bounce here and everything sits happy at like 5% where it was when we connected, then they need a new transducer and we can get the heck out of here. So how am I going to do that? I don't really need a jumper wire if I just use these guys. So we'll take our field device off. Good. Then we're going to go into not source mode. We're going to go into simulate mode, where we inject a foreign DC positive, and then this thing becomes a simulated analog device. And we can do that right here with DC2. Good. And with WX0. Good. So let's turn this on. Analog output. So we're sitting at 4 milliamps. Let's kick it up to 8. That's 25%. There's our status. That's way too high. Let's climb. Let's park it right at 4%. Keep going. There's 4%. So it's pumping out 4.647 milliamps. And if you look at our raw value there, the last two digits are bouncing between 60 and 58. So that's incredibly stable. Let's try put it in auto and see if we still get all that chattering and bouncing. Yeah, that raw value is very stable now, right at 7,560. I'm not seeing the chattering, not seeing any of that. Cool. I think our input is good. Raise it up a little bit. Same thing at a slightly higher value. We're up at 5% now. It's at 7,800. 6.5%. 8,000. There, now pump 2 kicks on at 7%. So that's all it has to do is jump up above 7%, drop down to 4%, then the pump will turn off. And then if it jumps above 7% again, pump 1 will come on, then pump 2, and if it jumps even higher, they'll both turn on. So in the eyes of the computer, it's getting a level that's going up, down, up, down, up, down, rapidly. Okay. Fortunately, this sump has a backup float mode, so we can leave it in backup float mode, and we can tell the operator that they need a new level transducer. Going to tuck those in like so. Yeah, look at it go. That transducer's toast. Tuck it in like so. Take a photo for the operator, so if they are the ones who change it out, they can put the wire back on there. And if they call me, I can just text them that picture. We can disconnect our laptop. If we don't connect the transducer, it's going to stay in a fault mode and the strobe is going to keep flashing. So I need to let the operator know why the strobe is flashing. And then it will switch over to float mode and run after that. Basically, the strobe is alerting them that the transducer is damaged. This failure mode on the transducer is remarkable in that instead of failing to 0 milliamps or a dead short and having greater than 24 milliamps, it's failed right in a tight little bandwidth, and the signal is bouncing like crazy. So that's a dangerous failure, because the PLC didn't think the transducer signal was a problem. It thought the sump or the wet well level was actually bouncing that much. So it's interesting. I wonder if we could set a fault parameter for speed of change, but I don't know. At this point, this seems redundant enough for the application, so I don't think there's any real design change that needs to happen. All right, see you on the next one.